Hey everyone, so if you've been following along, I've been working on this project called NFT-Magic, where basically you can upload a zip file that has a config. It describes a bunch of layer folders, and it's going to take those images that are in the layer folders and combine them into random NFT images using some type of rarity delimiter. And you can go to this website here at this URL. I'll put it in the description below if you want to try test it out. But basically the idea is you upload the zip file that has all your layer images, and it's going to combine them all and generate a zip file back for the user with all the images that they want generated. So for an example, if you go to the config file and you change total to like 10,000, it's going to generate 10,000 NFTs. And the issue, the whole point of this video is that generating 10,000 NFTs can actually take quite a bit of time. So if I click upload here, let me go ahead and go to my server that's running this. And you'll see that it has to loop over and kind of generate 200 images. And then it's appending them all to the zip. And the issue with this is I don't want users sitting around for like 5 minutes waiting for their NFT zip to be generated, because this, I think this could be achieved at a much faster pace using parallel processing. But anyway, so the idea is right now in the code, let me show you a diagram. Again, the whole point of this video is to show you my process of how do I design and refactor parts of systems. So let me show you the current kind of way this application is working. So a user will upload a zip file here. Hopefully you guys can see that. They upload a zip, and that's going to hit this API, which basically extracts the zip. It creates a bunch of random DNAs. A DNA is basically like, if you have like 4 layers, it's going to select image 1 from layer A, image 3 from layer B. It just randomly creates a bunch of like images, puts them together, and then you have like a DNA string that kind of tells you what images make up the final random NFT. So after you create the DNA, you basically load the image layers. So you load all the images that are in the layer folder. So you have to actually pull it in from the file system into memory. And then you have to create an NFT. So basically you have like an HTML5 canvas. You append all those images on top of each other. So if you have like a bunch of layers, that's going to take a lot of extra time to, conjoin 10, 15 layers together. And then finally, you have to take all those images and put them in a zip. So as you can tell, like doing all that work can be a lot of processing power. And the thing that I think we can kind of pull out into its own parallel processing is these 2 steps. So when you create a 10,000 NFTs, you generate basically 10,000 unique DNA strings that can be used to know what files need to load in and how to combine them together, right? So which image from which layer and how the ordering should work. So if we can kind of create a bunch of DNAs, we can send them over to different workers that happen to be on the same machine, and those workers can kind of extract the DNA, load in the images, and create an NFT image based on that DNA. So that's the idea. So this is what I typically do. I'll draw a diagram to kind of help me understand how we're currently doing things, and then I'll go over and make a new one to kind of explain a potential process to speed this stuff up. So let me share that with you. Basically, you have a user who's going to upload a zip. That's going to hit one Express API, which is going to generate, 10,000 DNAs. So if one user uploads a zip that has 10,000 in the config file, that is going to generate 10,000 events to be worked on by batch workers. So one of the best ways to do like parallel processing with workers is to use something called a event queue, or like use like ActiveMQ, RabbitMQ, some type of event bus or message broker. And there's like so many terms for this, but basically you push a bunch of events onto a message broker, and then you have these little workers that are kind of consuming these messages, doing some work, and then basically either writing files or sending results back to the original master node who kicked off the process. So that's what we're going to do. Is we're not going to use a message broker because I think it's just going to be a lot of extra complexity. What I'm going to do is just have these be separate Express applications. In fact, if I wanted to, I could keep these all the same Express application and just have them call each other or something. But I think it might be easier just to pull this apart and have it be a separate Express application, which has a single endpoint that takes in a DNA. And once it gets that DNA, it's going to basically read in the image layers. In fact, I don't even have that documented. Let me go ahead and document that real quick. So if I make another folder here, again, just drawing diagrams is one of the best ways to understand like your system, how it works, how you can improve it. A lot of people just write documentation. They don't really like draw diagrams. So this is going to load in some DNA. Let me put a little 3A, load in layer images. So based on whatever DNA it gets, it's going to load in the images. We could potentially cache them in the worker if you want to, because sometimes layer images are going to be used multiple times in multiple DNAs. So loading the layer images, hash them, and then we are going to basically generate, using the HTML5 canvas, the NFT image, and then we're going to write it to a file. And then at some point, this master endpoint is going to know when all of these workers are done. And it could just basically run a zip command over that folder and send the zip back to the user. So there's a lot of things that, you know, I could debate, like, do I want to use a message broker? Do I actually want to write to disk, or should I just send over the images over the REST call or something? But ultimately, at the end of the day, it's like, these are just really small trade-offs. Maybe it'd be faster not to write every image to the file system and then have to reload it again. Maybe it's better to just keep these in memory, and it might be a lot faster. But then again, you might start running into limits with sending a bunch of data over HTTP, because who knows how big these images could get, right? So there might be some type of limits here with the message broker, if you're using a message broker, or if you're just doing straight up REST calls. Like, I don't know. It's one of those things where you have to kind of experiment to kind of see like if this approach is going to work. But honestly, they're both really simple approaches. All three of them are pretty simple approaches. And when you have a complex domain like this, just pick one approach and just try it. And if it works pretty good, then just stick with it. If it seems like it could be improved, then that's when you go back and you try those other approaches. Like, figure out how slow would it be to write all these to file system and then zip them again. If I can end up achieving this in like 5 seconds of 10,000 NFTs, then your problem's solved, right? You need to keep on looking into the problem to try to squeeze out an extra 2 seconds of performance if the total process takes 5 to 10 seconds and users are happy with that. So I guess what the whole point of that last rant was is just keep it simple. Do the first thing that comes to mind, experiment, make sure it works, and implement it. And then later down the road, if you find out that, you know, the experiment that you did or the first implementation you did was kind of naive, then you just have to go back and you have to refactor it. I see a lot of people spend a lot of time trying to design stuff up front, but they don't actually know what's going to happen. Right? I could spend like hours trying to design like the perfect way to make this super performant, and then you start implementing it and you realize that your design has a huge flaw and you need to go back and redesign it. So keep the design simple and go implement it, and then you'll get some feedback. Keep that feedback cycle really short so you can see if you're doing the right thing. Anyway, that's what I plan to do. Probably in the next video or two, I'm going to kind of refactor my code and kind of show you the before and after progress of, did this actually make any changes? Did it make this stuff faster? And then I'll kind of give you a code walkthrough when I have these different workers built up. So be sure to like this video if you enjoyed watching me kind of walk you through my process of how I redesign or refactor parts of a system. Also, leave me a comment below if there's a different way or a different tool that you like to kind of draw diagrams, or you like to plan out in your head how you plan to implement some logic or design some type of system. And also be sure to click the subscribe button and bell icon if you want to get more videos like this in the future. That should hopefully help you become a better web developer or programming in the future. All right, happy coding and have a good day.